Hello, everybody, and welcome again to yet another OpenShift Commons briefing. And this one we waited for a while. We've had some scheduling conflicts with Khash and his team, so I'm really pleased to have Cloud66, a new member to the OpenShift Commons, talking about bringing policy as code into Kubernetes. So I'm going to let Khash introduce himself and the topic and explain what he means by that.
Great. Well, thank you very much. Thank you, everyone, for joining us today. My name is Khash. I work for Cloud66, and today I wanted to share some of the stories that we had to, the problems and the challenges that we had to overcome when we wanted to move our own application into Kubernetes. And as a result of all those challenges and problems that we had to solve, we had to build a product, open source a bunch of other ones, and I thought it's a great opportunity now to share this with you. If it's helpful to anyone, that would be great. For us, it's a great story, as well as that. If anybody wants to, ask any questions, please feel free to have that at the end. That we can moderate that. So to get started, I wanted to talk a little bit about the concept of Kubernetes Day One and what I mean by that. So when Kubernetes started to become a more prominent and popular concept around running containers on public or private cloud, we found out that getting it up and running is quite a challenge. It could be difficult to set up a Kubernetes cluster in a secure and reliable and highly available way. And that problem was gradually started to go away with the help of a lot of open source tools, a lot of good folks around who helped out, whether it's on GitHub issues and GitHub repositories, as well as webinars like this one, and people like Chorus, Red Hat, OpenShift itself is a great way of running Kubernetes. And kind of by the end of 2017, we realized that setting up a highly secure and highly available Kubernetes cluster is becoming easier and easier. With the help of tools like GKE, which is Google's managed Kubernetes, OpenShift, and Amazon Web Services, just coming into this market with great products and offerings like ECS, EKS, and Fargate. So day one of Kubernetes, which is setting up your cluster, is getting easier, and it's becoming more available to everyone. Have a good running cluster. And this kind of leads us to day two of Kubernetes, which what I see as day two. So now, day one, we had the Kubernetes cluster. What's going to happen in day two? Now you have a Kubernetes cluster, you have access to it, you can run anything you want, and it's a clean, empty cluster. And that is where we started to see most of the challenges that we had to overcome. So just to give you a little bit of background, Cloud66 is a SaaS product that we sell to our customers through cloud66.com. And this service had been running on AWS for about 4 years before we decided that we want to put it into containers, move it up to Kubernetes, and run it on GKE in this particular instance for various different reasons that we had. And that journey led us to kind of realize this day one, day two kind of a journey at the same time, the tooling and the build up that we had to do for that. As a company that has a good in-house experience on running Kubernetes and setting up Kubernetes cluster, we didn't have that much of an issue on day one. We could set up a Kubernetes cluster in hours, if not shorter than that. But once we had the Kubernetes cluster running, we realized that our application, while it's containerized and while we had the Kubernetes configuration files for it, there's a bunch of things that we couldn't do, and there's a bunch of things that we were not really confident doing. So the way I look at a Kubernetes cluster is like a vending machine. If you walk into an office building, it's very likely that you see a vending machine packed with candies and cookies and other things that might be there. And it's kind of like as if a Kubernetes cluster is a vending machine that operations guys, the ops, build for developers to consume. It's a resource that's available, is made available internally. So by the end of day one, we have the vending machines installed everywhere. Now developers can come and use it. And in order for this vending machine to be usable for every application that is in-house or from third-party vendors that want to provide us with services on top of this infrastructure setup, we need to use configuration files. We need to use and craft and apply configuration for our application into this. This could be in terms of Kubernetes services, deployments, daemon sets, replica sets, ingress, storage classes, persistent volumes, network settings, and all the different things from a variety of developer-centric concerns and operation-centric concerns. And that is the first challenge that we had to overcome. So the best thing about Kubernetes is that everything is a resource. From an application service that is running to a port and a firewall and a load balancer, they're all equal and they're all resources. And that makes a very good, that makes it a very interesting thing for everyone, operations and developers within an organization, to have a unique and a uniform view of the infrastructure by looking at these resources. So you can look at the configuration file and tell that this IP address belongs to the firewall, while the other IP address, for example, or service name is a database that's provided. And that's a great thing, which was not available when we had to deal with recipes, for example. But this also presents a challenge where, as a developer, I can technically go and make a mistake in my configuration file and change a storage class. And that will potentially can bring everybody else within this infrastructure setup to affect everybody else and bring the application down. One of the if we want to go back to the example of a vending machine, technically what I can think of is like I can go to this vending machine and I can put a dollar bill in there to get a cookie, and that dollar bill can make the corkscrew go backwards and get the whole thing jammed. And while this is not really something that you would imagine would happen with a normal vending machine, it's quite possible that as of now we can have those kind of issues with the Kubernetes cluster. Now, there are setups out there like RBAC, for example, role-based access control that Kubernetes provides that can help us as operators of Kubernetes clusters to stop accessing some of those resources by people that we don't want to give access to or have some control over it. But that then creates another challenge, and that is if you take away access from some team to make a change into a cluster, then there are always legitimate needs for those changes to happen, and that means you either have to grant those on a case-by-case basis, on a resource-by-resource basis, or you would have to build up an approval process where changes are put into an approval request, and like something like a pull request, and you would have to, or you or your team have to review that and then approve it, and then for it to go out, it can get merged back into the mainstream configuration repository where it goes out and hits the cluster. And just by creating that parallel flow of approval, we realize that we can potentially create misalignment between the teams who want to roll out a service within the organization. For example, our developers decided that they want to use a search service within the application, and that search service was very easy to be added to Kubernetes setup as a service and a deployment in a replica set. But for that change to happen, we needed approval from the ops guys, so we had to fork out the repository that holds the Kubernetes configuration files, make our changes, roll it back into a pull request, wait for it to be approved, and make sure that the changes that we put in go after the approval has hit the cluster, so we actually have the resources we want for the application to run. And that just creates a hiccup within our continuous build and deployment flow, where we would like to be able to just commit code, commit configuration, and then see it in production after the tests are happening. So that was the first thing that we realized we needed to do. The first thing was that we need to have a multi-repository approach to code and configuration to be in lockstep together without the approval process being in the middle of the way, while having the oversight from different teams to make sure that everything goes in lockstep and nobody can break the vending machine they want. That was the first kind of thing that we wanted to do. The second one that we realized was about enforcing conventions, standards, and best practices. Some of those conventions that we have, for example, are around naming conventions. As you break your application up into tens, if not hundreds, and sometimes thousands of microservices, how would you configure the Kubernetes cluster for each one of those services? Would you put everything in one file, or would you split them based on the type of service? For example, replica sets on one side, storage classes on another file, deployments on another file, or would you break them up even further into each individual deployment or each individual service? And then how would you go about naming them in a way that you can find them in a convention-based way? And also, how would you know what's the application order if it's not the same file? A lot of times we construct a single file that's kind of appended, everything is appended together, one after each another, and then we can then apply that with the kube control command onto the Kubernetes cluster. But as we break these files apart into individual parts, individual files to make them manageable and more maintainable, we lose the cohesion that these have in terms of the order that would apply. So that's another challenge that we had to kind of think about. The third problem that we had to think about was secrets. So ideally, we wanted to deal with secrets in a way that is Kubernetes native. We know that Kubernetes has two sets of ways of injecting configuration into application. One is through config maps, which is non-secret configuration key value pairs. And the second one is secrets. And both of them are treated in Kubernetes the same way. They are applied onto the cluster either through command line or a configuration file. We wanted to go with a way that the entire application can be deployed from one file or a set of files every time in a reproducible way. So we can scaffold these, what we call formations, or the entire stacks end to end, by just applying a kube control to a file and then having it up there. And having secrets in those files was a no-go. We couldn't put secrets into files and commit them into source control, because then that would create potentially exposed secrets. And there are ways around that where you can replace those secrets with placeholders and then use other third-party tools like SOP, for example, is another one, or pull it out of a vault and replace them at the end. But then this tool chain requires to be built. So you need to have these templates with secrets as placeholders, and then have a secret or secure server somewhere that will then pull out the real secret and put it into the file and apply it without any manual intervention or anywhere that some eyes can see those secrets and they get leaked. And that was another challenge for us that we needed to overcome. Sometimes we've seen that secrets are committed into files, but the files are then encrypted, which then takes away the entire benefit of using Git and diff and version control for those files, which is not very ideal. And the last major kind of challenge that we had was we broke our monolithic application into multiple microservices, and we deployed it to Kubernetes, and everything was fine, and we kind of overcome a bunch of those challenges. But then we realized that as the complexity of application or the configuration grows, we are pushing out complexity from one place to another. Namely, we had one application that was very complex. It was one monolithic application, a very big beast that we had a lot of complexity inside of that. And we broke it apart into smaller pieces, which was great. It made the application much simpler, every piece understandable, and more importantly, we could assign each piece in one of those microservices to a specific team, so they can be responsible for that. And they have these contracts and agreements between each other, and how to talk to each other, how the APIs work, and everybody can be very autonomous and release and roll out on their own life cycle, and it's great. But then the flip side of that is the complexity needs a home, and the complexity goes from application to configuration on the infrastructure side. And we needed to make sure that we have the conventions, the tool sets to manage that complexity. Now, I have to say that managing complexity on the infrastructure side is much easier than managing complexity on the code side. And the reason for that is not that, as developers, we are not really good. It's because the toolbox, the tool chain and tooling that's available for us to manage complexity on the infrastructure side is much more objective and much more available and widely used and accepted as best practices, which potentially makes, admittedly makes the entire concept of DevOps, while managing complexity on the code side is a very subjective thing about, the cohesion of a function or the complexity of a method, which is something, You can argue for hours, if not months, around which way is the better way. And that led us to heavy use of annotations within Kubernetes. So every asset that we roll out have to be annotated in specific ways and in specific parts, so we can trace every asset, whether it's a deployment or a service or an ingress controller, all the way back to the code, to why was it released, when was it released, what was the change, how many versions of it are in flight at any point in time. So those 4 areas about enforcing conventions, standards, and best practices were things we had to solve and we had to overcome and find and devise either solutions for, or go out and find out if anybody else has done something about it and we can benefit from it. All of those collectively led into 2 main products, and one main product and one open source project. The first product that we rolled out as a result of our effort to make our move to Kubernetes work was called Cloud SkyCap stencils. Now, stencils are like templates for Kubernetes resources. And it is worth here for me to mention another CNCF product or project called Helm, which is a great package manager for Kubernetes, where we looked at and we used initially, and we still do use for parts of it, and kind of the reasons as to why we decided to do stencils instead of heavily investing on Helm itself. So the first thing that we did was use Helm for everything. And now Helm, for those who might not be completely familiar with it, is a package manager, as advertised, package manager for Kubernetes. It is kind of like NPM for Node.js, but for Kubernetes, or Ruby gems, or Go Get, things like that, where you can you have vendors who or software developers would package things into these Helm charts, and then you can then do a Helm chart install and use it on your Kubernetes cluster. The first thing that we saw was, as advertised, Helm is a package manager, and we don't install our application with NPM or we don't install our application with GoGet. We use NPM package manager for Node, or Ruby gems for Ruby Rails, or GoGet, or in Windows and .NET World, Nuggets for packaging dependencies of the application during development. But when it comes to deployment, there are other tools that we use to deploy, i.e. compile, obfuscate, encrypt, scan for security vulnerabilities, rollout in terms of the rollout or the deployment steps, database migrations that could go potentially out, A/B rollouts, canary releases, and all sorts of things that come with different methodologies and paradigms of deployment that we wanted to make sure that we can do and we can benefit from. And a package manager, just by definition, is not necessarily something that you want to overburden with all these functionalities and features. That was the first reason that we started thinking about having stencils. The second thing is, while we started building Helm charts for our application, we realized that they're very powerful tools, and like as the saying goes, with great power comes great responsibility. It's kind of sometimes difficult to harness that power in a way that's reasonable and manageable and traceable. So we had cases that we started with one Helm chart, and it was for one service, and then we ended up with a for loop in there where we would repeat the same Helm chart for multiple services that we had, and they were identical. And sometime down the line, in life cycle of application, as things happen, one of those services started to behave slightly differently, so we had to put an if statement in that loop or break the files apart, and then the complexity started to creep in more and more and more. So when we started thinking about stencils particularly, we wanted to deliberately take out flow controls from that, especially when it comes to the fact that this flow control and templating language is used to generate structured data like YAML or JSON, where most of the templating languages that are out there are generated or created for generation of not so structured artifacts like HTML, for example, for rendering web pages, and kind of the tools are not necessarily fit for purpose. So stencils deliberately don't have flow controls, and they're much more simpler, and they also understand the paradigms of deployment to Kubernetes. The second tool that we built and we open source is called Copper, which is a Kubernetes configuration validator, where we wanted to make sure that we give access to the vanilla upstream API of Kubernetes to our developers, where they can do whatever they want to do, and they can use, the community, Stack Overflow, or everywhere they go and research the problems they have, and they can apply those solutions to the Kubernetes cluster they have, obviously with RBAC on top of it. But we wanted to make sure that we don't have to wrap Kubernetes API in yet another API to just restrict it down and make sure nobody breaks the vending machine, by having some sort of unit test for the configuration file. So we would allow developers to write the configuration file however they want, but then we would apply copper rule files to this to highlight things that should be stopped, or things that need an ops person to come and verify and validate before the person, we can apply it to the Kubernetes cluster. So with all that build up, I wanted to show you a demo of what we've built, and a simple demo of a single page application with a single service that we deploy to a Kubernetes cluster using stencils. Hopefully it's going to be adding a little bit more color into what I said about the tools that we had to build. So let me switch over to SkyCap dashboard. So SkyCap has a concept of an application, and I can start using that. So I start a new, what we call an application. I give it a name. And here I can just add services to this. So if my application consists of 10 microservices, I can just add them one by one here, or I can add them as a YAML file, which looks very much like a Docker Compose file here if I want to, or you can use the command line if you want to leverage more power. But the simplest way is to just simply use the UI and give your service a name and bring it in. Now, here you can have each service come from different places. You can get it from a Git repository where SkyCap pulls out the code, builds it for you, and then the artifact is then pushed to a private repository, all of it provided by SkyCap, but you can bring your own repository if you want to. You can build it on your own machines if you want to, or you can simply just choose to deploy a pre-built Docker image, whether it's an off-the-shelf Docker image or some other Docker image that your CI/CD tool might build as part of your pipeline. Here, I'm just going to choose one repository that we have. It's a simple Hello World application written in Go with a little bit of HTML. I'm just going to paste the repository, use master as the branch, and click Go. So what's happening now is just SkyCap's going to pull out the code, have a look at it. Oh, it found the Docker file. Great. So it will be able to build it. And I'm going to click Next. Now, while this is being built, I'm just going to go to the application and show you the app. It's a very simple Go application. If you're familiar with Go, it does nothing very fancy. It just serves a web server on port 5000 and then serves a web page that's out there with a bunch of JS and CSS. And the Docker file that it has is a very simple one. It uses the native Golang official base image. It does take the dependencies of the web and runs the build on the machine inside of the container itself, and then you can just run it. So here, the application now is created. It has the web service as we defined it, but no snapshots have been taken, i.e. no image has been built. So the first thing I do is I just click on snapshot, and what this is going to do is going to pull down my code, run it on what we call build grid, and then generate this. Now, this is all available on cloud66.com, which is a SaaS service. You can just sign up for it and use it, but this is also available as a download and as an on-prem solution as well. I can go and export logs as they are being built. So these are the log files of the build. As we saw, that's exactly the same Docker file that's being built, and then it's being pushed into a Docker registry as a result. Okay, so the build's now done. It's just for finishing off the last parts. Okay, great. Now I have a choice of how I want to deploy it. When I set up deployment, I can deploy with Maestro, which creates a Kubernetes cluster for you on any cloud or bare metal, and you can just simply deploy the entire application onto that. But today I wanted to show you the stencils and formations. So let's just do this. So when I go to formations, I can create multiple formations here. Now, what is a formation? Formation is a result of another realization we had during this about the inadequacy of environments. Now, traditionally, we have like a few environments: production, staging, UAT, QA, development. Some companies have a little bit more, some companies have a little bit less, but usually it's not more than 6 or 7. Very rarely we get to about 10 environments for an application. But with an aim of being able to deploy the entire stack end to end with a single file, and not only that, multiple of those instances of application on a single cluster, we realized that the concept of an environment is not going to cut it anymore. For example, we have customers who run Cloud 66 on-prem, and admittedly they are production, so the environment is production, but one customer's production is different from another one, so we call them differently, and we call each one of them a formation. Sometimes you want to have the entire application deployed with specific features hidden or as a canary release somewhere, so some of your customers can see it, or when your client might want to sign off on it, and you call that a formation as well. This is what we call formations. So I'm going to go to formations. I'm going to call it my formation. Now here we have a repository for the stencils. Now these are the two that I've connected to my formations. The base template essentially is a Git repository with a sample of how every asset within Kubernetes has to be configured, and I'll show you that in a minute. So I'm going to use one that I have here, and I'm going to save this formation. Now, before I create any stencils, let me show you what that base template repository can look like. So this is a simple base template repository. So the way it is it's a normal Git repository. It has one file, a metadata file called templates.json, where it has metadata around each file that's available. But when you look at every one of those files, it's a Kubernetes normal Kubernetes configuration file, with the difference that it has these placeholders that are filled out, and that's what a base template for a stencil is. For example, my ops guys want to make sure that every time I create a new namespace, it is annotated with this annotation. So they make sure of that. Or they want to make sure that every time I deploy a service, my service is named as such. There are some specific things that should be there. Or for example, they want to make sure that I don't forget to specify the ports, the internal and external port of my service. So they put this placeholder called require, which will then stop the deployment operation if I fail to provide this value. And I'll show you this in action. So now that I have my formation, let me add my first stencil. Right. So my first stencil comes from this set of base template stencils that I have connected to this. I'm going to start with a setup. Obviously, I need a namespace. So this pulls down my base template for setup for namespace. And this part is just a simple Kubernetes namespace that I have with the annotations that my team requires as a convention. And the second part is interesting because this adds the Docker registry credentials to my namespace, so all the images that I have can log in, or the pods can log into my Docker registry and pull the images down. As you can see, we have placeholders like registry credentials, which then just understands how you've connected your SkyCab to a Docker registry, how Kubernetes consumes those secrets, and all the sort of things around that. This is all backed by a Git repository itself, so you can pull these out on your favorite browser, favorite text editor, and then with a Git client without having to go through UI. But here I'm just going to, for the sake of this demo, I'm just going to use the web UI, and I have a commit message, which is a Git commit message, and I add my first stencil. So now my formation has one stencil. I'm going to add another one, which is going to be a deployment, because I want to deploy my service, my pod. Again, here, if you're familiar with Kubernetes configuration file, you'll see that this is a normal deployment configuration file with these placeholders. And you can, for example, see that my naming convention or my ops guys want me to have this naming convention, for example, use the name of the service with a dash dep at the end to just for the naming convention, for example, to be enforced. And here I want to be able to enter the port, so there's a require there. If I forget to do this when we get to the rendering part, what we call rendering this formation stencil into a Kubernetes configuration file, a fully fledged Kubernetes configuration file, this will stop and show up as red, so we need to fill it out. I believe this application runs on port 8080, if I'm not mistaken. Oh, sorry, 5000. So there we go. Port 5000. So I'm going to replace this with 5000. And I'm going to take out the command that I had in the Docker file as the starting point. So now I have everything that I need. I'm going to say add deploy as my commit message. You can tag it as well. Everything is taggable. All right. And the last piece that I need is I have the deployment, I have the namespace, I need to have a service. A service, again, is a normal Kubernetes service. For the external port, I'm going to use port 80. For the internal port, obviously, it was 5000, and I think the rest can be left out. Again, you see that the naming convention is the name of service with -svc, because that's what is the convention within our team, and we can be enforced. Now, we can delete these if you want to, and this is going to still work. There's nothing wrong with that. If you want to make any changes in the base template, you can do it here, or you can do it in the base itself, so it's applicable to everything. But if you do this, and if it is something that's mandatory by your team or by your development manager or ops guys, then they will have policies written to ensure that these things are present in your configuration file, and they will stop the deployment because those policies are not met, and those are enforced with COPPA, which we can get into a bit later. Adding service. Okay, so now I have my namespace, my deployment, and my service. Now, remember that we were talking about how the concatenation of these files work in once when it comes to rendering a single file that can be applied to Kubernetes. So here I can just drag and drop these to make sure that service gets created before the deployment or deployment before the service, so I can, or namespaces after all of them, which is not quite right. Obviously, you want to have the namespace before everything else. And Kubernetes being Kubernetes, it's not going to break anything. We can apply everything twice. When we run it, if the Kubernetes doesn't have the namespace at the beginning, we can run it again, and the next time we will have it, but we just want to make sure that it works the first time. So we put it in the right order, and that's basically what we want. And I can then render this formation. It will force me to click on this here as a guide. And here you see that we have the files rendered with all the values filled out, following my conventions. Now, what I can do here is I can download each individual file or select a subset of them and download them as one file. But easier than that, we can use the command line that we have. So I'm going to copy the command line, switch over to my terminal. So if I have a kube control, I have a Kubernetes mini kube running on my local machine here, which is clean. If I run this command, and all I need to do is now just select the right accounts, because we have support for multiple accounts. I'm just going to run it with the right account. Here you see that all the stencils that I created are rendered at the right order and concatenated. So this is ready for me now to apply to my Kubernetes. So I can just pipe that to kube control. And I have my namespace, and that's running. So this is my deployment. Let's see what my service is called. There we go. It's called web service. Now, because this is Minikube, we need to see this. We're just going to use the Minikube command. We'll then open up the browser, and there we go. So it's now deployed. All it took for me to deploy one service. Obviously, it's a simple application. It's a single service application, but you saw how easy it is to create a service from source code, compile it, push it into a repository, generate the configuration files for Kubernetes for it, and deploy it to a Kubernetes cluster. I can simply just switch my Kubernetes kube control to a different cluster with a config use context to another cluster that I want. And by that, I can then apply the same command and deploy the same application somewhere else on another cloud or another Kubernetes cluster that I want. There's a lot more in stencils around secret management, different versions, a tagging of existing images to be deployed with the same tag as with my build applications, having actions that you want to happen at every deployment, like database migrations, for example, or other things around creating subsets of your entire application that just renders a subset of your stencils so they can be deployed. For example, when you want to have a deployment that only consists of a subset of your services or deployments, or making changes to specific ingress controllers or any other assets within Kubernetes. So that is kind of a demo of the stencils. And quickly, I'm just going to run over to Copper.sh, which is the website for open source product called Copper, which is a validator for Kubernetes, and show you the some of the examples of things that you can do with it. It's very cool. I think it's very useful for a lot of folks that we've met. So one of the things that we see, for example, is that we want to ban use of the latest tag on the images that you see on Kubernetes configuration files, because obviously that's not best practices. You don't know what you're getting, which version is coming down. And sometimes if you don't have a policy of image pool always, for example, it might have a stale image because it's still called latest. And for that, this is a simple DSL, domain specific language, that Copper will understand. You can create a file, call it, for example, nolatest.cop, and you can write this in it, and then it would apply that to a Kubernetes configuration file. And as you can see here, it's a JSON path that will go and fetch all the image names that it can find within my configuration file. Then it will look at them as image names, so it understands that, for example, if you don't have a tag, then it's latest. If you don't have any repository, then it's Docker Hub. Then pick the tag, so it understands those intricacies of syntax. Then if it says it's latest, then it fails this rule, and the rule is of type ensure, so it will stop the deployment. You can have it integrated in your CI/CD. SkyCap has support for this in a native way. You can also do other things, like I want to have minor upgrades of one of the components, not a major one. So it will go and pick up the version of your image from MySQL, and it would pick it and understands semantic versioning, and says with versioning condition check that it can only go get upgrade from 5.6 minor upgrades, not major. So you won't be able to upgrade it from 5.6 to 5.7 without having it first checked, but any minor upgrades are satisfied. Some of these checks can also be around enforcement of file names. For example, you want to make sure that if you have a deployment in a file name, then your file name should have the word file name in it, and the extension should be YML, for example, not YAML or something else. Or you want to make sure that the IP address for load balancer is within a range, so by mistake it doesn't get changed, for example, or the namespace is always something, not the default one by mistake. You want to make sure that you don't pull images from Docker Hub, for example, or you always want to make sure that no image is pulled from anywhere except for your private registry. These are some examples of things that you can do with Copper, and you probably want to write some of those examples and share with others as well. But you want to use this as part of your tool chain, and it's very easy to use as well. You can just write the file and then do a Copper check with the file and the configuration file that you want to check, and it will give you a pass or fail, and that's pretty much it. As I said, with formations in Cloud 365 SkyCap, there is a native support for stencils. On the policies, you can just enter your copper files right here, and you can say where they apply to. For example, you can say kind deployment, and this will apply this policy file that you have on any deployment Kubernetes deployment assets type that you have, and it will stop the deployment or just stop the rendering of the formations as a result of that. That's all I wanted to kind of share with you today around what we had to build and open source, just to get over the kind of tool set and the build pipeline that we wanted to have around build and deployment pipeline of deploying our own application to Kubernetes, and we shared it as a product and open source project. I would love to hear your feedback and questions around how we use this. If you can find or think of any other tools that could be complementary to this or even replace these ones, would love to hear that and talk about it and see how we can improve this either product or our best practices and workflow as a collective to move adoption of Kubernetes forward. Thank you very much for your time.
Well, thank you, Khash, for taking the time to share this with us. I mean, Copper sounds like it, and I hadn't heard about it until you did today's presentation. So now I'm going to have to go back and dive into that a little bit more and a little bit more deeply too. It's wonderful when these things are out in the open source. From my perspective, it's the stencils can you just clarify a little bit for me? The stencils, are they a replacement for Helm, or are they a substitution for Helm charts?
No, they're complementary to those. So what we actually do ourselves is we do use Helm ourselves as well. We use Helm for off-the-shelf things that we get. For example, if we want to have a Redis as a component of an application deployed, we use the Redis Helm chart because it's written by people who know how to run and operate, for example, Redis or MongoDB or RabbitMQ on Kubernetes best, and they can do a much better job than we can do ourselves. So we use the Helm charts for those things, and when it comes to deployment of our applications, we use stencils. So it's kind of complementary together.
And how does this work, perhaps in relationship to operators? Very closely at the
operators. Yeah, so operators are great and very, very powerful concepts that we can use. Sometimes we see that, just give you an example about operators. For example, admission operators that we use for immutable webhooks, where we want to inject something as a sidecar into every pod when it's, I believe we use it for Istio when we want to have, traffic management, making sure that traffic to every service goes through Istio. So we use those instead of going around and changing every single configuration file. So we use, the operators for that purpose. Stencils is very much about a repeatable, auditable, and traceable way to generate configuration files. Because regardless of whether you use operators or you don't use operators, we use sidecars or we don't, we use RBAC or we don't. Well, I hope everybody uses RBAC. We always need to finally build configuration files and apply them to the cluster, whether it's to deploy the operators or whether it's to deploy the application itself, or even change the RBAC settings. So the good thing about Kubernetes is that it always works off of a configuration file, one or more configuration file. And that's the best way to use it. Obviously, we don't advise anybody to go and create, secrets or configuration files using kube control as a command line. So hopefully everybody uses, files that are repeatable. And the entire existence of stencils and formations are to make it easy, traceable, and policy friendly way of creating configuration files, regardless of what you deploy to the Kubernetes cluster.
Well, we've been having a little chatter in the background while you've been talking in the chat. I think you've answered everybody's questions. There's a couple of folks there. I'm giving them a few seconds if they wanted to raise their hands and ask questions. I think what we're all going to do is go back and watch this video again so that we can get some of the nuances, because I'm really interested to see how this works out deploying on OpenShift as well. Because you said you had done this on GKE, and I'm curious to see if anyone's using it in relationship to with OpenShift yet.
So we actually do use it with OpenShift as well. This is actually one thing that we did about probably a couple of months ago. Instead of piping it to kube control, we just did it to OC and just did the same thing, exactly the same thing. We didn't have to change pretty much anything around this. And one of the good things that formations do is you can create these slight variations between some of the parts of your stencil while keeping everything else the same. An example of that could be that if you develop and you want to just deploy something onto Minikube, probably you don't have a load balancer. I mean, you definitely don't have a load balancer on your machine, so you don't want to have a service that's exposed as a load balancer. So you can create that tiny variation while you deploy the same thing to, say, AWS. You want to have it as a load balancer, or you want to deploy it to OpenShift. You just deal with it slightly differently. So there are some very, very minor variations that you can create in that. One example that we ran, it was a simple application that we deployed to GKE, Minikube, DigitalOcean Kubernetes, and OpenShift with the same application. Everything is exactly the same without a single variation.
Cool. Good to know. So hopefully we can get some feedback from some of the OpenShift users and move, maybe have a demo of someone using it live in production on OpenShift sometime in the not too distant future. And a number of the folks that are on are heavy duty Jenkins middleware people from Red Hat, and so they're quite interested in Copper and other bits that you've done. So I'm guessing we're going to have you back a few more times. So thank you very much for taking the time today. And if you can send me your slides, I will put all of this up on our YouTube channel shortly and get you some resource links connected, so we can connect the dots for the rest of the folks in the community that watch this.
Definitely.
Not too distant future.
Definitely. I mean, definitely. One thing about Jenkins and Copper itself, we also have another open source project that we see a lot of usage with Jenkins. It's called Habitus. You can find it in Habitus.io. I'm just going to type it in the chat, and we'll share it with you as well. And it's a what it is. It's a workflow build workflow for Docker, and you basically can build a cascade of building step 1 and then step 2 and then step 3. But it's more that it goes beyond that. It allows you to two things that are very unique to Habitus. One is that you can take out an artifact from one build step and put it into another one, which will help with a lot of differences between runtime and compile time requirements of an application, shrinking the attack surface, making the images smaller. And the second thing it does, that it allows you to inject secrets, serve secrets during the build time for Docker. And this is very useful when you have private Git repositories or private repositories that are dependencies of your build time. For example, you have a dependency that's in a private Git repository, you need to have the private SSH key to access it, or a secret commercial enterprise version that you need some sort of key to access it, and you don't want to build that into the image because it is going to be there forever and might potentially leak it out into public. So it will allow you to do it in a secret, in a safe way. I would encourage you to check that out as well. It's again open source, and it would be very, very useful for anybody who's using Jenkins and Java or Go, any compile language.
Perfect. Well, we'll definitely give you some feedback on that, I can tell you, and we'll take a look at that as well. And hopefully we can get some collaboration going with you on those two open source projects and work through using some of this in other workflows as well. So thanks again, and we'll put this all up on YouTube on the RH OpenShift channel, and it'll get out into the wild, and hopefully we can get you some feedback on all of this from our community. Thank you.
Definitely. Looking forward to it. Thank you very much. Thank you.